Hello everyone, welcome to Marketing Research course MMPM006, session number 24 of this course. Title of this session is One-Way Analysis of Variance. Now, learning outcome of this session: specify the assumption involved, explain the steps involved in carrying out one-way analysis of variance, state hypothesis concerning equality of more than two population mean values, prepare analysis of variance table, draw conclusion based on analysis of variance table prepared and F distribution. Now, what is analysis of variance? And in short, we call it as ANOVA, that is analysis of variance. This is a powerful technique for comparing population means of more than two populations. Here, the methodology that is followed is we partition the total variability present in the data set into different components. Each component is attributable to a separate cause or factor. So the total variation in the data set will be divided into or split up into different components, and each component is attributable to a separate cause or factor. In addition to one attributable factor, we have an additional component called the random component, which is always present, random component. This random component accounts for the repeatability of the result. That means when we repeat the experiment, when we repeat the trials, when we repeat the measurement process, we may not get the same results, and that variability in that we call as the repeatability of the results. This is also called experimental error. In general, analysis of variance is used for testing the equality of the population means, mainly two or more population means. In case of one-way analysis, we have one attributable factor. So there is one attributable factor, and then in addition to this, there is one component which we call as a random component or error component, which is always present in all measurement or all data observation or all in process or in all processes. One-way analysis, where it is used for testing equality of several population means, mainly more than two population means. When we have two population means to compare, we use t-test. But when we have more than two population means to compare, we use what is called the analysis of variance. For example, comparing mean life by 5 different tire brands or products. So here we have 5 different types of tire brands, and we are comparing them for the mean life. Comparing strength of 4 different materials. So we have 4 population. In the first case, we had 5 population. Another case could be comparing effectiveness of 4 different teaching or training methods. So we have 4 population to compare, and we will be using one-way analysis, or in short, we will call it as one-way ANOVA. What are the assumptions which we will be required? That is, population values are normally distributed. That means the values in each of the populations follow a normal distribution. Populations have equal variances. That means the standard deviation same for all the population. Samples are randomly and independently drawn. Trials are done under homogeneous condition, that is, all background factor remain same throughout. So all background conditions are remain same, only the attributable factor is allowed to vary. Here we have one example, give you an idea about how the data looks like. So we want to see if 3 different batteries are having different mean lives. That means we have 3 batteries, battery 1, B1, we can call it as battery 2, B2, and battery 3. So each battery, there are 3 different brands, and we want to know whether they have the same average life or not. So we randomly select 5 samples from each type. So we have taken a random sample of 5 from a production of battery 1 or from brand 1, and similarly sample size 5 or 5 units for brand 2, similarly 5 units from brand 3. So in all we have 15 batteries, 5 from each brand. So randomly selected 5 samples from each type and test them at 5% level of significance. Is there a difference in the mean life? So we have 3 samples of size 3, and we are interested in comparing the mean life of these 3 brands. So we have 3 population means. So we are interested in comparing whether the average battery life in 3 cases is same or not. So what will be the null hypothesis? Simple. H naught will be equal to mu1 is equal to mu2 is equal to mu3. That is, the mean life of the first brand is equal to the mean brand of second brand is equal to the mean life of the third brand. That is, alternatively, we can say all population means are 3. That all 3 population means are equal. Against the alternative hypothesis, not all the population means are equal. That means at least one population mean is different from the remaining. So 2 could be same, all the 3 may be different. So they are all different number of possibilities. So we can put them in the form that at least one population mean out of the 3 is different from the remaining. So this is the hypothesis to be compared, and for this we use one-way ANOVA. If we had 2, we could have used t-test. Now how to carry out? So the approach for the ANOVA is simple. We divide the total variation in the data set into 2 components. So this is one-way ANOVA. One-way ANOVA means one attributable factor and one random component. So we are going to divide the total variation in the data set into 2 components. What are those 2 components? Sum of square among the batteries, that is factor, and sum of square within batteries, that is within the battery. Within a battery, we have 5 samples from each battery, also called random component, and determining the degree of freedom associated with each. Then we calculate mean square value for each component by dividing the sum of square value by the corresponding degrees of freedom. Then we calculate F ratio by dividing the mean square for among batteries by the mean square value for within batteries or the random component. So we take a ratio of the mean square for the between batteries and within batteries. And this ratio we can show follows F distribution. So here we will be using F distribution. So we have F stat follows F distribution, degrees of freedom for the numerator and the denominator in the F ratio. So F ratio or F distribution is another distribution which we use in the analysis of variance, and it has 2 parameters. Since F ratio is the ratio of 2 mean square values, so F distribution has 2 parameters. One is the degree of freedom for the numerator, and another is the degree of freedom for the denominator. So it has 2 parameters. Critical region lies in the upper tail of the F distribution. F distribution is again a positively skewed distribution, and it depends upon the degrees of freedom for the numerator and the denominator of the F ratio. Now let's see how to do the analysis part. Now we have 5 batteries. Let's look at the total variation. If we look at the total data set consists of 5 plus 5 plus 5 till 15 data points. Now 15 data points, if we look at, the data values are varying. The minimum value is 197, if I can see, and the maximum value is 263. So there is a difference in the battery life which is varying from 197 to 263. Where do we attribute this? Why there is a variation in the 15 data points which you have? We can get an idea about the range. Range is the maximum value minus the minimum value. Minimum value is 193, maximum value is 293. That means the amount of variation present in this is varying from 197 to 263. Now the question is why there is a variation, so much variation within the three samples. Now one possible reason could be the difference in these values may be because of difference in the batteries. That is one factor which is attributable, because all other factors for testing the battery, they were kept same. That means we use the same person, same instrument for checking it, same environmental condition. So all the background factors were kept same. They were not allowed to vary. They could be the different meters which we use, different temperature, humidity, the person. All these conditions were same for all the 15 samples. So the only difference that we can find or attribute is the difference in the 3 brands. So this is one attributable factor we have identified, that is maybe a difference in the 3 battery brands or difference among the brands. Now, we look at the first sample. Let's look at the first sample. In the first sample, the values are 254, 263, 241, 237 and 251. Now, if you look at these 5 values, the brand is same, all other conditions are same, still the life is not, still the life of these 5 batteries from brand 1 is not same. Why there is a difference? When the brand is same, the background conditions are same, everything is same, but still there is a variation. Now, this variation is not attributable to any factor. So, the variation in the first battery or the 5 observation battery 1 is not attributable to any identifiable factor. So, this variation we call as random variation. So, this is random variation which is present in battery 1. Similarly, look at battery 2. In battery 2, if we look at the minimum value is 216 and the maximum value is 235. Why there is a difference from variation from 216 to 235? Where do I attribute this? So, we do not have any reason for that because the brands are same, all the 5 batteries are from the same brand and we have used the same background condition for testing them, still there is a variation. So, variation in these 5, in the second sample is again attributable to a random variation or random component. Same variation we find in the battery 3. All the 5 values are not same, though the brands are same, the 5 samples are from the same brand, the measurement process is same, the environment under which is done, the person who is doing also same, still there is a variation from minimum is 197 and maximum is 222. So, where do I attribute this variation? Again, I do not have any identifiable factor, so I will say that it is because of the random component or error component or repeatability. Repeatability is when you do the same thing under same condition, we may not get the same result. So, we are testing 5 batteries of the same brand, made under same condition, tested under same condition, same environment, still the values are not. So, the variation these 3 will is also because of the random component. So, we identified one attributable factor, that is difference among the batteries possible. Second is the random component which is present in all the 3 batteries and all the 3 samples. Battery 1 is population 1, battery 2 is population 2 and brand 3 is population 3. Now, how do we do that? So, what we will do is, we will divide the total variation is split into 2 parts. One is SST, which is the total sum of squares in all the 15 values, which is equal to sum of square among groups or among batteries or among brands. Third is sum of square SSW, sum of square within batteries. So, one is between batteries, another is within batteries, within group and between groups or among groups. So, total variation in the 15 value will be split up into 2 components, variation or sum of square between groups or among groups plus sum of square within a group or within a brand. So, we split up the total variation into 2 components. How to do? We will see that. So, that is the total variation in the data set will be split into variation due to battery factor plus variation due to random component. And sum of these 2 variation will be equal to the total variation in the data set. Then we also put this information in the form of a table which we call as degrees of freedom. Let's have a look at how ANOVA table looks like. ANOVA table has number of rows and number of columns. First column is corresponding to the source of variation. Second column represents the degrees of freedom for different component. Third column represents the sum of square values and the fourth column represents the mean square, that is the estimate of variance, and the fourth column represents the F ratio. We have 3 rows. First row represents the among variation, among groups, between brands. Third is within groups or within batteries. And last row is total. Coming to the degrees of freedom, if we have n samples, the total degree of freedom will be n minus 1. In our case, we have 15 samples, so degree of freedom will be 15 minus 1. Now we have 3 groups, so degree of freedom for among groups would be C minus 1, that is 3 minus 1, that is 2. And within a group variation would be n, the number of observation minus the number of groups, which would be equal to 12. Now, we calculate the degrees of freedom for each component, we calculate the sum square for each component, then we put it in the form of ANOVA table. And we divide the sum of squares with the corresponding or degrees of freedom to get the mean square values. So mean square value for within group and mean square value within group. Now we compare these two ratios. If the null hypothesis is true, the mean square because of between group should be same as mean square within group. So we take the ratio of these two mean squares, and if the ratio is very high, obviously the null hypothesis is not true. To get the cutoff value, we use what is called F distribution. F distribution is another distribution which is used in the testing of variance and in analysis of variance, which is a ratio of 2 chi-squares. So this is how an ANOVA table will look like. So we will do the analysis and put the data in the form of ANOVA table and then compute the values. So null hypothesis mu1 equal to mu3, and at least two populations are different, and F statistics. F statistics is the ratio of among estimates of variance and with an estimate of variances. So we take the ratio of the estimate of the variances. This can be shown follows F distribution. F distribution again is positively skewed. It has a longer tail towards the right, but it has two parameters. One, that is two set of degrees of freedom. One is degrees of freedom associated with the numerator of the ratio and the degrees of freedom associated with the denominator. So degrees of freedom would be C minus 1 and minus 2. And we go to F distribution and then calculate the cutoff value and then use the standard procedure for deciding whether to accept or reject the null hypothesis. Now we will go through an example. We will show you how to calculate the total sum of squares, how to calculate between groups and within square, total sum of squares, degrees of freedom, make the ANOVA table, carry out the F test. So we continue with the same example, 3 brands, 5 samples for each brand, 15 data points, and so on. First thing is we calculate the mean value for each group. That means for brand 1, what is the average life? For brand 1, the average life is 249.2. Similarly, find out the average for brand 2, which is 226. Similarly, we find out the average life for the brand 3, which is 205.8. Then we also find out the overall average. That means average of all the 15 values or average of these 3 values, which is equal to 227. So the overall average of all the 3 groups is 227. Average for the first sample is 249.2, average for the second sample is 226, and average for this third sample is 205.8. Now these values are graphically shown in the graph in the form of a graph, 3 batteries. So we have the values in the form of dots for each sample, and we have the average value, x1 average for the first sample, x2 average for the second sample, x3 average for the second, and then we have the overall value. So we want to know whether there is a difference between these means or not. So one-way ANOVA computation, how do we carry out the calculation? First we find out the sample mean for the first brand, second brand, third brand based on 5 observations. So we have the averages for the first one 249.2, x2 bar, average for the second sample 226, and average for the third sample 203. Now to find out the sum of squares among the groups, we will find out the variance in the 3 sample means. The variation in the 3 sample, that means values 249.2, 226 and 205.8. So we will find out the variances between them, which is given by, so what is the overall mean of all these 3 values? That is 227. So we will find out the difference between the first sample mean and the overall mean. So 249.2 minus 227 and then square the value and multiply by 4 because it is based on total of 5. Then take the second sample. The mean is 226 and the overall mean of all the 3 samples is 227. So 226 minus 227, square it, multiply 5 because there are 5 values on this. Similarly for the sample 3, the sample average is 205.8 minus the mean of all the three, which is 227, square it, and then multiply by 5 and add all the three values, which we get is 4716 point. And the degrees of freedom is 2 because we have 3 brands, so degree of freedom associated would be equal to 3 minus 1, that is 2. Now coming to Within variation. Now within the variation will come from 3 components. What is the Within variation for the first brand? What is the Within sample variation for the second sample, second brand? What is the Within variation from the third brand? So we will find out the variation, the first 5 values of the sample 1. Similarly, we will take the next 5 values of the sample 2, find the variation between them, and we will take the 5 values within sample 3 and compute the variances within each of them. So the first value, mean of the first value, sample mean is 249.2 and the first value of the sample is 254. So 254 minus 249.2 whole square plus second value in the first sample is 263 minus the mean of that, so on. And then we go to the second sample value 234, the mean of the second sample is 226, square of that, and so on till we do the same thing for this. So when we add all the 15 values, 5 value corresponding to sample 1, 5 value corresponding to square values corresponding to sample 1, 5 square values corresponding to sample 2, 5 square value, we get what is called the overlap variation or within variation, which is equal to 1196 with the degrees of freedom 12. Because if you look at each sample has 5 values, so degree of freedom associated with the first sample is 4, degree of freedom associated with the second sample is again 5 minus 1, that is 4, degree of freedom associated with within variation for sample 3 is also 4, so 4 plus 4 plus 4, that is 12 degrees of freedom. Now we divide the corresponding sum of squares by the corresponding degrees of freedoms. So mean square among groups, which is 4716.6 divided by 2, which is equal to the mean square between groups. So among group it is 2358.2 and mean square within group is equal to 1119.6 divided by 12, which is 93.3. Now under null hypothesis, both these mean square among groups and mean square within groups, they estimate the sigma variance. So we take a ratio of these two. This ratio we call as F stat, which is a ratio of 2358.2 divided by 93.8, and the ratio is 25.275. Now this ratio we have to compare with the value which we get from the F distribution. As I said, F distribution has 2 parameters, that is degrees of freedom associated with the numerator of the F stat and the F statistics, and the degrees of freedom associated with the denominator. The numerator has 2 degrees of freedom and the denominator of F stat has 12 degrees of freedom. So we will be using F distribution with degrees of freedom 2 and 12. Now here is a detailed description of how do we calculate the total sum of squares and all that. So total sum of squares will be calculated by each value for each value is subtracted from the grand mean and then square. So 254 and square it and dub it over, and total sum of square is equal to 5836, and sum of square within sample is equal to variation in sample plus variation in sample, variation 3. Now this information which we have collected or compiled is put in the form of a table which we call as ANOVA table. So this is how the ANOVA table looks like. This is called one-way ANOVA table. Again, it has columns, heading with column heading, source of variation, degrees of freedom, sum of square, mean square, that is the variance, and F ratio. So among batteries, degree of freedom is 2, sum of square value which we found is 4716.4. Now get the mean square. That means to get the mean square value, we divide the sum of square values by the corresponding degrees of freedom. That is 4716.4 divided by 2. So we get a mean square value of 23,2358.2. Similarly, we do for the within battery variation, 12 degrees of freedom, and sum of square is 1119.6. So if you divide the sum of square value by the 12 degrees of freedom, we get an estimate of 93.5. Now we compare these two estimates of sigma under mean square. We take the ratio. To compare this ratio, if this ratio is close to 1, that means the null hypothesis is 1, true. But if the ratio is large, obviously we mean there is a big difference between batteries and within battery variation. So if this ratio we take, the ratio comes out to be 25.27. So 25.27, that means between variation is 25.2 times more than the variation within batteries. Now the null hypothesis, as we said, is mu1 equal to mu2 equal to mu3, and alternate hypothesis not all are equal, and the cutoff value which we will have to get from corresponding degree of freedom 2 and 12. Because numerator has 2 degrees of freedom, denominator has 12 degrees of freedom, and the cutoff value which we get from the table is 3.89, and F statistics is 25. So we reject H0 at alpha is equal to 5%. So there is evidence that at least one of the mean value differs from the remaining. Now here we have the F distribution table. The column here, the columns gives the degree of freedom corresponding to the numerator of the F stat, and the first row gives the degree of freedom associated with the numerator, and the first column gives the degree of freedom associated with the denominator. So in our case is 2 and 12. So under 2 degrees of freedom for the column and 12 degree of freedom from the column, we can get the chi-square value, F value, and F value comes out to be 3.86. Hence we reject the null hypothesis. So since F ratio is 25.27, F value for table for degrees of freedom 2 and 12 is 3.89. So F ratio is greater than the table value of 5%. So we reject the null hypothesis of the equality of the mean life battery. So our conclusion is that the mean life of 3 batteries are different. That means the 3 batteries do not have same mean life. There are some batteries with more mean life than the other, and the interest may not lie between finding out which battery has more life than the others. So here what we have done is, basically we have tested population means for more than 2 populations. The null hypothesis consists of comparing population means using analysis of variance technique, and this analysis of variance technique is based on splitting the total variation in the data set into 2 components. One component is attributable to the batteries, second component is not attributable, so we assign it to the random error or the component. So we split up the total variation in the data set into 2 components. We also get the corresponding degrees of freedom. Then from the sum of squares for each component, we divide by the degree of freedom to get the mean square, and we take the ratio of this mean square to get the F statistics, and we use the F distribution to get the cutoff value. As I said, F distribution is 2 parameters, degree of freedom corresponding to the numerator of the F ratio and the denominator. And accordingly, we take the decision whether to accept or reject. So these techniques will help us in differentiating 3 populations or more than 2 populations, and finding out whether they have the same population means or there are some populations which have higher mean than the other. Thank you so much. Thank you for your kind attention. Thank you so much.